We're going to demonstrate the professional features of Mastermind by Genomenon, our comprehensive genomic search engine. So now that you have an account, you're going to be able to perform searches using our professional edition features. So today I'm going to show you first how to use some of the different filterings through ACMG and AMP, as well as show you supplemental data and give you an overview of the user interface. So we're going to start with a gene TP53 that we expect to have multiple genetic changes, perform our search, and this will take you to the user interface where you'll see the variant diagram. This is organized by protein position, and it starts at the beginning of the protein and goes to the end of the TP53 protein. All along the way, you can see the different variants, and we are able to capture both somatic and germline variants within this diagram. You do have the capability, especially when there are a number of variants, if you would like to zoom in, you can do that with your mouse. You can also immediately see, looking at the variant diagram, the number of articles that are associated with each protein position. Down below, you'll see the list of protein positions as well as their cDNA correlates. And this is organized at the outset by the number of articles, so 2.7 thousand in this case for one particular variant location. But I will show you in our next iteration how you can narrow that down so that you can just focus on a particular variant of interest. On the right side, you're going to see all of the publications at this point associated with the TP53 gene. Down below, you will see the publications displayed in order, and this will allow you to view sentence fragments after you click on the article of interest. With our publication history diagram, there is, it's clear based on the axes, the year of publication, and also the number of citations by journals. So the higher up this dot location, the more frequently cited the reference is. And the size of the circle has to do with our relevancy score. So the more relevant an article is deemed to be based on the number of gene and variant mentions when we get to adding a variant, will prioritize the relevancy. Also, other considerations like where the gene falls within the body of the text, so the abstract, the full text, or the supplement, and how many times it appears. So given that we have a lot of information that we would like to pare down, what now we'll want to do is to filter categories. After you have examined your gene of interest, you can narrow down by filtering categories. You'll go here, and we have several different categories related to ACMG and AMP criteria. If I'm specifically wanting to look at inherited variants and differentiate them from somatic, we have several different keywords under this tab that will correlate more with germline versus the somatic. So you can see things like report type. You can also see transmission within a pedigree. You can see different inheritance. You can also see de novo, germline, and somatic. So in this case, I'm going to go ahead and apply germline filters. This number beside the word germline is indicating how many publications containing TP53 have that as a keyword, and germline hyphenated as well. Then I'm going to submit with my chosen filters, and the information will be reorganized to preference those articles that contain germline, and it will be approximated next to the TP53 gene so that it will be weighted accordingly. Then if I want to further narrow by looking at a specific variant, I can enter it by the cDNA position or protein position. So here you can see my variant. I'll just add that to my search. So now you can see that between the combination of adding my germline filters and now narrowing to a specific variant, I will have the information rapidly reorganized down to just 4 articles that are deemed most appropriate. This is how you can quickly view information, including information that's in a supplement. So this paperclip designates supplemental material, and I can quickly see in my sentence fragments exactly where my gene and variant is mentioned throughout. So that concludes the first demonstration showing the basic overview of the user interface, ACMG and AMP filtering, and supplemental data. We're going to demonstrate intronic search with this example. So we're going to search the gene BTK, and then we're going to add a cDNA position. You see that this is populated with my variant that I entered. However, what I want in order to maximize the sensitivity of my search is to be able to find all of the different nomenclatures that could represent this variant. This is one capability of Mastermind we want to be sure to highlight. So when you see the BTK L522SA, that is indicating that this is a likely splice acceptor variant. There's a list of the abbreviations we use for this Mastermind terminology on our frequently asked questions page. So I'm going to select this, and now I'm going to see the output with 7 articles matching this normalized Mastermind nomenclature. Then I can see exactly which variant is being represented when I look at my sentence fragments. So I'm going to view my article, select variants only, and then I can immediately see the cDNA position being represented as well as the transcript information. If I am to scroll through toggling and looking at different references, I can see immediately that there is other nomenclature that could also represent this variant. The power of Mastermind is the ability to pull all of that information together in one search and quickly review it so that I can effectively determine if this variant represented in the paper is consistent with the one in my patient that I am trying to analyze. For this example, we're going to show what to do when a variant is not present in Mastermind, which can be very reassuring in the sense that if it's not present in the database, it's very unlikely to have ever been published. We refer to this as the power of 0. So if I am looking for a SMARCA variant, specifically an indel event, I'll select, and in this case, I get a 0 output search. One advantage is that you still can create an alert for this search. You can simply select this button that will create an alert. You can also review your alerts at any time by going to the alerts button at the top of the page, select my alerts. And a new enhancement is that we have allowed for alert sharing as well between your team members if you have the professional edition. So these are the alerts I have previously set up. At any point, I can edit my alert, stop my alert. I can also see the notifications from past alerts where I've received emails about new articles. I can also at any time share with my group members. So since I have the professional edition of Mastermind, you'll see below that other users from my same organization are highlighted here. I can select them and then I can share with them and determine the interval in which we receive notifications from weekly, monthly to quarterly. A use case you may have is the ability to query loss of function variants within a particular gene. I'm going to illustrate this capability with the gene Titin. I'll first perform a search which will load all of the variants across the gene, and then I will apply a filter specifically related to loss of function. To do this, I'll go up to filter categories, go to genetic mechanism, and in this area, we have several different filter types for the impact a variant may have, including gain of function and loss of function. The numbers adjacent to LOF and loss of function indicate how many articles contain this keyword. I can select these 2 options, submit with chosen filters, and this will allow the literature that contains the keywords of LOF and loss of function to be applied. and my relevancy score will be reassessed at that point, with the most relevant articles appearing with the largest circle and at the top of the list below. Further, I can layer this search. So if I wanted to see which Titan loss of function variants correlate with a certain phenotype, I can add the phenotype into my search here. You can see that my filters are still applied. And now I will get the new literature output that connects all three of these concepts, again, rapidly prioritized and filtered. In order to see my keywords below, I can select all matches, and this will show me my gene, the variants that, if I had searched for a variant, any variant that was entered, and in this case, loss of function as my keywords. I can also see my phenotype in the output. This search will show you how to look for a gain of chromosomal information, as well as combine different phenotypes to see any associations. For this example, I'll do a gain of chromosome 14. You can select right there in the CNV option, and then to combine the phenotypes, you can enter those for your patient, in this case, hydrocele, and then hypothyroidism. Whenever you want to add more than one phenotype, you'll want to hold the shift button and return in order to have them both populate. Otherwise, one will replace the other. You can see that the default then is to combine literature that contains both the hydrocele testes and the hypothyroidism into one search as associated with my CNV. So I'll first perform it this way to see if there is any literature with both of those keywords. In this case, there is not. So I will select now, or just by clicking on the word, this will broaden my search so that I can find any literature related to exact or overlapping CNVs and my two phenotypes of interest. Then when I'm viewing the publications, I can see them here rated by relevance and explore my phenotypes and the CNVs as they appear by looking at my sentence fragments and selecting all matches. In this example, I'll show you how to look for deletions within a gene and organize them by the order of exons. So for this example, I'll look at LMNA. When I type in DEL, that will indicate to Mastermind that I want to explore deletions within the LMNA gene. You see that the genomic coordinates for the gene are populated by Mastermind. Then I'll just complete my search and I will see in the output both the exact matches and overlapping CNV containing deletions in LMNA. The top priority will be those with full gene deletions, and I can see that there are 672 articles. If I sort the information by start position, I can actually see the deletions that are within the gene as well. So publications here that are related to exon 13, it looks like there are not any. In this case, I can see a very small deletion within exon 12, larger deletion here, 120 length of base pairs. So if I want to explore any of these associated literature articles, I can then select here on the number 3, and the information will be reloaded. So now I have the 3 articles related to that smaller deletion, and I can explore them. So in the output here, it will show the exon 12, and it will show it's the deletion and then LMNA. For this example, I'm going to show you how you could complete a Boolean search if you want to see CNVs that could be either lost or gained frequently. So for this one, I will do a deletion of 16p11.2. The cytoband genomic coordinates are populated when I enter in that way. And if I also want to see gains of 16p11.2 and associated literature, I'll type with amplification, or if I want to put gain, the same result will occur. So Shift and Enter will allow me to populate the search bar. If I left this as and, I would see literature that contains information both about my deleted cytoband and amplification within the same article. I'll broaden it in this case by changing and to or. This will allow me to see the literature related to either deletions or amplifications of 16p11.2. I'll then perform my search and I'll get the output with both deletion and amplification and exact matches organized at the top. So I can see on my CNV diagram the 128 genes within this CNV region. And I can see here the literature that relates to the deletion at the top. I can see that there's 1.4 thousand associated articles at this time. And for the amplification, I can see that there's 974 associated articles. I can further refine this search by adding phenotypes and other filters if I want to refine the output. For this search, I'm going to show you how to select a phenotype and get associated genes of interest. So I'll enter craniosynostosis as my phenotype, or as a disease in this case. So our HPO is what we use for our phenotype terms, and the disease are based on mesh. When I perform my search and I haven't entered any genetic information, this will launch our associations page. If I want to look at the genes that are contained within the articles that relate to the phenotype of craniosynostosis, what I will see is the genes and how many articles they are cited in. This demonstration will show you how to examine certain therapies and their associations with diseases and genes. So we'll start out with vincristine, which is a chemotherapeutic agent. It can have side effects in those with Charcot-Marie-Tooth disease. So I'm going to search for Charcot-Marie-Tooth and this therapy of vincristine so that I can explore literature related to those two occurrences. If I want to also see the genes that underlie this association, I can go to the genes tab and immediately see the most common gene that might be involved, which is PMP22. If then I want to explore just the PMP22 associations, I'll add to search, and then I'll be able to view my evidence simply by selecting the View Evidence button. Now I can see the 46 articles related to my concepts of vincristine, Charcot-Marie-Tooth, and the PMP22 gene. For this search, I'm going to explore the variants that are associated with DSP and arrhythmogenic right ventricular cardiomyopathy. I'll start the search by putting in my phenotype here. And then I will look at the DSP gene, perform my search. I will be taken to our user interface that will show me the literature associated with the disease and gene. And if I'm not familiar with the variants that might be associated and want to explore that further, I can view that here, or I can also look in our associations page. I can see my variant listing here, organized by those with the most articles. And then if I want to explore any of them in more detail, I can add them to my search. You can see that it's reapplied. And further, then if I want to see if there's any therapeutic implications of the variant gene and in the context of this disease, I can click on the Therapies tab. This loads different therapies that then I can explore simply by looking at the intersection of literature. So I'll review these 10 articles. It's immediately populated, and I can view all matches in the output so that I can see where the relevant information is highlighted. If I want to look up information about somatic cancer, particularly fusions, What I can do is enter the gene partners of interest, in this case, ETV6 and NTRK3. I'll add them both to my search by holding my shift bar and selecting. In this case, I will want to keep the "and" so that both genes will be entered in my search and I'll be able to find articles that contain both of them. To look for fusion information, what I can do is go to my filter categories, genetic mechanism tab, and the fusion events. And then I will just apply fusion as a keyword. So when you see these numbers, 1424 or 1421 indicates that there are that many articles with the keyword of fusion, 67 containing fusion event, and 635 with fusion gene. To be most comprehensive, I'll submit with the chosen filters. And then I can see the output of articles that relate to the fusion. I can also explore if they're associated with a particular cancer type or narrow down based on that cancer type. So in this case, sarcoma. I'll just add my phenotype, reapply the search. And then in the output, I can explore the information about my fusion and its association with the disease by reviewing the articles easily and matching for all. This way I can see anywhere my fusion happens to be mentioned, the keywords that are relevant, as well as the cancer type. I'll illustrate here how you can search for a deletion within a single gene and its association with cancer. So for this search, I want to look at deletions of EGFR. I'll select that as a CNV. And my patient has glioblastoma, so I immediately want to correlate with phenotype. So I'll enter the glioblastoma, perform my search. What this will show me is exact match CNV data as well as overlapping. So there's one gene of interest and the exact match information will be highlighted at the top. There are a number of articles and 430 of them also contain my disease of glioblastoma. So if I want to narrow the articles down to exact CNV information, I'll just reselect to only look at my exact CNV, and then I can see my 430 articles of interest. This search will demonstrate our associations and the power that can be revealed. So I'm going to use a somatic cancer example where I'll look for the gene ABL1, select that, perform my search. And in this case, I want to explore other fusion partners that might be observed. So I'm going to go to my filter categories, genetic mechanism, fusion events, and I'll apply all of the fusion related filters of interest, submit with those filters, and then the associations page, I'll be able to view other potential fusion partners since my filters are still applied by going to genes. In this gene list, I can see other genes that are referenced in the article containing fusion and ABL. So as you might expect, BCR ABL is the top occurring match. I'll add that to my search then, and then reapply it. And now if I want to explore the other diseases and phenotypes that may occur with BCR ABL, I can do that by going to my diseases tab. This is very powerful in the sense that you can know very little about a particular gene or fusion, and then you can immediately see what the available literature is that exists and what the main correlations or associations are in the literature. So it can be a powerful tool, particularly if you're learning about a new subject area or in the research setting. For more information, you can refer to our website at genomenon.com, or you can email us with any questions at support@genomenon.com.